Hello everyone, and welcome to another video. Today, we're diving into the concept of subtraction. So, what exactly is subtraction? It's the mathematical process of taking one number away from another. In my previous video, we explored addition, and subtraction is essentially its opposite. While addition increases a number's value, subtraction reduces it. Let's look at a simple example, 8 minus 5. If we were adding, we would increase 8 by 5, but since we're subtracting, we decrease it by 5, giving us the result of 3. Now, let's learn how to subtract two-digit numbers. Take this example, 29 minus 15. When performing subtraction, always start from the rightmost digit and work your way to the left. First, we subtract the ones place. 9 minus 5 equals 4, so we place 4 in the ones column. Next, we move to the tens place. 2 minus 1 equals 1. That gives us the final answer, 14. Now it's your turn to practice. Try solving these. 14 minus 3, 39 minus 18, and 59 minus 27. Let's begin with the first problem. As per the rule, we start with the ones place. 4 minus 3 equals 1. Now, moving to the next digit, we see that there's only a 1 with no number beneath it to subtract. But here's an important fact. Every number has an infinite number of invisible zeros to its left. However, don't assume these zeros exist on the right, as that would change the number's value. Since subtracting 0 from 1 still gives 1, our final answer is 11. For the second example, we start with the ones place. 9 minus 8 equals 1. Moving to the tens place, 3 minus 1 equals 2, giving us a final answer of 21. Now, for the last one, 9 minus 7 equals 2. In the tens place, 5 minus 2 equals 3, so the final result is 32. But what about subtracting numbers with more than two digits? Let's try 153 minus 31. Starting with the ones place, 3 minus 1 equals 2. Moving to the tens place, 5 minus 3 equals 2, so we write both 2's in their respective places. In the hundreds place, we only have a 1 with no corresponding number beneath it. However, every number has invisible zeros to its left, and subtracting 0 from 1 still gives us 1. Thus, the final answer is 122. Using this method, you can subtract numbers with 3, 4, 5, or even more digits, as long as you move from right to left. Let's take things up a notch, shall we? Before we move forward, I'd like you to pause the video and try solving this. 51 minus 27. In basic subtraction, we usually subtract smaller numbers from larger ones. Here, 51 is greater than 27, so let's proceed. But wait, there's a problem in the ones place. The digit 1 is smaller than 7, so we can't subtract directly. What do? In such cases, we use a method called borrowing or regrouping, which is similar to carrying in addition. We borrow 1 from the 5 in the tens place, reducing it to 4, and add that borrowed value to the 1 in the ones place, turning it into 11. Now, we subtract. 11 minus 7 equals 4. Moving to the tens place, we now have 4 minus 2, which equals 2. So, the final answer is 24. You might be wondering, beta, how does borrowing actually make sense? To understand this, we need to look at how numbers are formed. Every number we use is based on the number 10, a system known as the decimal number system. Numbers are structured into columns, called place values or digits, where each digit holds a specific position. It all starts with the ones place, which represents single units. Moving to the left, we have the tens place, followed by the hundreds, thousands, and so on. Each digit has a specific value, known as its weight, which determines its contribution to the number. The ones place has a weight of 1, the tens place has a weight of 10, the hundreds place has a weight of 100, and this pattern continues, with each place value increasing tenfold as you move one digit to the left. In the previous example, the number 51 consists of 5 in the tens place and 1 in the ones place, which means it can be written as 5 times 10 plus 1 times 1. Similarly, 27 can be expressed as 2 times 10 plus 7 times 1. By the way, the times symbol represents multiplication, which we'll explore in detail in the next video. Rewriting the subtraction problem, 51 minus 27 becomes 50 plus 1 minus 20 plus 7. Since 1 is smaller than 7 in the ones place, we borrowed 10 from 50, reducing it to 40, and making 1 become 11. After performing the subtraction in both place values, we were left with 20 plus 4, which equals 24. Now that the concept of borrowing is crystal clear, try solving these on your own. 17 minus 8, 50 minus 12, and 132 minus 58. The first one is easy, the answer is 9. For the second one, since 0 is smaller than 2, we need to borrow 1 from 5, reducing it to 4 and turning 0 into 10. If you're writing this out, you can note the borrowed 1 in small text to the left of the borrower, / the lender, and write its new value as a superscript above it. Now, 10 minus 2 equals 8, and 4 minus 1 equals 3, giving us the final result of 38. Now, for the last one, 2 is smaller than 8, so we borrow 1 from 3, reducing it to 2 and turning 2 into 12. Subtracting, we get 12 minus 8 equals 4. Moving to the next digit, 2 is still smaller than 5, so we borrow 1 from the hundreds place, making 2 become 12. Now, 12 minus 5 equals 7. Since there's nothing left in the hundreds place, the final answer is 74. Pretty cool, right? Now, let's look at another example of borrowing, which is a bit trickier. Try solving this. 101 minus 77. At first, it seems like we should borrow 1 from the tens place since 1 in the ones place is smaller than 7. But here's the catch, we have a 0 in the tens place. So what do? In this case, we borrow 1 from the next available digit, which is the hundreds place, and add it to the tens place. This turns the 0 in the tens place into 10. Now, we can borrow 1 from it, reducing it to 9, and making the 1 in the ones place become 11. Subtracting, we get 11 minus 7 equals 4. Moving to the tens place, we now have 9 to 7 equals 2. Since the 1 in the hundreds place was borrowed away, it becomes 0, leaving us with a final answer of 24. Now that you've got the hang of it, try these 3 problems for practice. 103 minus 57, 201 minus 37, and 300 minus 157. For the first problem, 3 is smaller than 7, but since the next digit is 0, we need to borrow from the hundreds place. We take 1 from the 1 in the hundreds place, turning the tens 0 into 10. Then, we borrow 1 from 10, reducing it to 9 and making 3 become 13. Now, 13 minus 7 equals 6, and 9 minus 5 equals 4, giving us a final answer of 46. Moving on to the second problem, we see that the ones place has 1, which is smaller than 7, and the next digit is 0. So, we borrow 1 from the 2 in the hundreds place, reducing it to 1 and making the tens 0 into 10. Then, we borrow 1 from 10, making it 9 and turning 1 into 11. Now, we subtract step by step. 11 minus 7 equals 4, 9 minus 3 equals 6, and 1 minus 0 equals 1. This gives us a final answer of 164. For the last problem, there are 2 zeros in a row, so we borrow 1 from the 3 in the hundreds place, turning the tens 0 into 10. Then, we borrow 1 from this 10, reducing it to 9 and making the ones 0 into 10. Now, we subtract as follows. 10 minus 7 equals 3, 9 minus 5 equals 4, and 2 minus 1 equals 1. The final answer is 143. And that's it for today. If you enjoyed this video and found it helpful, don't forget to like and subscribe to my channel. See you in the next one.